going on, ladies and gentlemen? Welcome to another edition of Math with Mr. Stevens. You're going to need your math book. We're going to be in Module 4, as always. So we're just going to dive right in. What we're looking to do today is really to get a clean understanding of how we are looking at lines and how we are looking at the equations that these lines create, and vice versa. So we're going to be in Lesson 20 on page 242. Okay, so on page 242, this is where we are taking the next step in terms of our understanding when it comes to linear equations and the graphs of those linear equations. We have spent a little bit of time talking about the slope, talking about the y-intercept of these lines, and so we have to be able to understand what we're doing when we have the graph of a line given to us, and then we have to find the equation, we have to put the equation in some certain form, and then go in the opposite direction as well. So with this particular problem, question number 1 on 242, we're given a line. This line is here on a coordinate plane. We can see various points along this line that meet at whole values. So we can go here, we can go here, we can go here, we can go here. Okay, so there's 4 different potential places for us to find and use the slope. What we are doing here with this particular problem is first off creating the equation that represents this line. And so we're going to do that by taking this line and turning it into the easier of the two equation formats. So there is slope-intercept form, which is what we're going to start with, and then there's also standard form, which is, you look at the rest of the problem here in the directions, it tells you to go from slope-intercept form to standard form. So we're going to do that as well and look at the process that is required to make that happen. All right. Both of them represent the same thing. They are the same line. They are both equations. Their numbers may be a little bit different in their form, and the way they're put together, the way they're composed is going to be different. But it is still going to be representing this line that is given here. So the way we do this is we start with our slope-intercept form. We look for 2 things. Those 2 things are the slope and the intercept. Okay? The slope and the intercept. We're going to start with the easier of the 2 to identify right off the bat, and that is what's called the y-intercept. Essentially what we're looking for is, as we see our y-axis and our x-axis, where does this line cross? Where does it cut through the y-axis? Hopefully it's at a whole value, and with this particular problem and this particular set of problems that it's given here, it does. It cuts through at a whole value. All right? What we're going to use that value is, that's going to be half of our equation. So when we start our equation begins, as always, in slope-intercept form, as we have here, with y equals. It starts with y equals. From there, we're going to jump to the very end, which is the y-intercept. So we're looking for where along this vertical line here, the y-axis, where does it cross? And it crosses here at 0, positive 2. At 0, positive 2, this line crosses the y-axis. So what that means to us is, for our equation to represent this particular piece of information, is at the very end of it, we're just going to put a +2. Okay? That +2 tells us that our line crosses at 0, positive 2. For the y-intercept of a line in slope-intercept form, the y-intercept is always going to have an x and a y. It's a point. But that x value, because it's on the y-intercept, it's always going to be 0. Always. It's always 0. And so the number that's listed in the equation, in this particular case, it's +2. That tells us at 0, positive 2, that is where the line crosses through the y-axis. From here, we can look at this point, and then we can look at any other points that we would like to use to go from point to find our slope. So as we go from left to right, looking at how our line changes, we see that to get from here to here, we have to go up 1, 2, 3, and then 1 to the right. So that is going to be a positive 3 increase and a positive 1 increase. Remember, the coordinate plane is 2 number lines. You have a vertical number line and a horizontal number line. Going up on a vertical number line increases your value. Going down decreases it. Should make sense, like a thermometer. And then going left to right horizontally, as a normal number line as we see them, Going to the right is an increase, going to the left is a decrease. So positive and negative changes there. From here, we have to create what's called our slope. Our slope is a ratio. This ratio is represented as a fraction. This fraction is created by taking our vertical change and then dividing it by our horizontal change. So what this looks like is we're going to have positive 3 divided by positive 1. The reason positive 3 goes on top is that's our vertical change. We're increasing by 3 to get from this point to this point. Our change in y is an increase of 3. If it was a decrease, we would put a minus 3, but it's a plus 3 because it's an increase. And then horizontally is what our denominator is going to be. Our horizontal change of an increase of 1 is going to be our denominator in this fraction. So positive 3 divided by positive 1. That is a very easy, clean answer of 3. And so we're going to take this value of 3, which is now we've identified as our slope, and we're going to plug it into our equation where m goes, which is right here as our coefficient of x. So for this equation, or rather for this line, our equation is y equals 3x plus 2. This is our equation in slope-intercept form. To get to standard form is a little different. So what we have to do to get to standard form is, as we can see in slope-intercept form, x and y are on opposite sides of the equal sign. We have the y value on the left, x value on the right. In standard form, they are together. They are on the same side of the equal sign. They are unified. So what we have to do is we are going to leave the y value where it is, and we're going to move the x value. So as we are moving the x value, essentially what that allows us to do is our first step is going to be subtracting 3x from both sides. That eliminates x over here. That leaves us with a positive 2 on this side. And so now over here we have negative 3x plus y equals positive 2. This is not standard form yet. Standard form requires you to have a, which is the coefficient of x, to be a non-negative number. So that means either positive or 0. It's not 0, so that means in this particular case we have to make it positive. So when we do that, when we are trying to do that, what we have to do is multiply the whole thing times negative 1. Not just one side, but the whole equation itself. We're going to throw them into a set of parentheses, and we're going to multiply by negative 1. What that's going to do is that's going to give us a positive coefficient of x, which is what we have to have in standard form. So negative 3x times negative 1 becomes positive 3x. Negative 1 times y is negative y, and that's going to be equal to negative 2 times 1, or negative 1 times 2, which is negative 2. So this is our equation in standard form. 3x minus y equals negative 2. These two equations are different forms of the same thing. They are different forms that are representing this single line. These are not two different lines. They're the same line, different forms of the equation. Very similar to how we have rational numbers. They can be represented as a decimal or they can be represented as a fraction. It's the same value, means the same thing, it represents the same thing, just in two different formats. Let's look here at question number 2. Let's do the same thing. I'm going to go a little bit faster this time. Identify my y-intercept. So my equation begins with y equals something minus 1. I find where my line crosses at whole values. From here, I'm going down and to the right. So down is a negative 2 change. Going to the right is a positive 3 change. And so when I put these together as my ratio, as my fraction, vertical change gets divided by a horizontal change. So negative 2 divided by positive 3 is negative 2/3. This is your m. So in your equation, this is what it looks like in slope-intercept form. Y equals negative 2/3 x minus 1. That's it. To go from this in slope-intercept form to standard form, we do the same thing we did before. We need to add 2/3 x to both sides. So that gives us now 2/3 x plus y equals -1. And the reason that we added 2/3 x this time is because our slope is already negative. So this is a negative value, positive, cancel it out. That's the point. So now we have 2/3 x plus y equals -1. Now you might be tempted to say, well, let's just divide everything by 2/3. We can't do that. The reason is that in standard form, a, b, and c all have to be integers. If we multiplied everything or divided everything by 2/3, we would essentially just take this 2/3 and move it to y, and we would move it to -1. So we would have 2/3 y, and we would have -2/3. That doesn't help us. So what we have to do is we have to multiply by the denominator of the fraction. So in this particular case, our fraction that I'm talking about is 2/3, and our denominator is 3. So what we're going to do is, again, we're going to take the whole equation, and we're going to multiply it by 3. The reason we're getting rid of the denominator is so that way we no longer have a fraction. We just have a whole value. So 3 times 2/3, 3 times y, and then 3 times -1. This is already positive, so we don't have to worry about that. That's a nice thing. If this were a negative fraction, then we would multiply by the negative value of whatever the denominator is. So if this was a -2/3 x on the left side, then we would multiply by -3. So that way we would make it a positive whole value. So 2/3 times 3 is 2x. 3 times y is 3y. 3 times -1 is -3. So in standard form, this is what your equation looks like. This is our process. This is what we have to do. We have to be able to go from this to this to this, and then from this to this to this back again. This is our task. This is what is required for us at the 8th grade. If you have questions, send me an email. Ask me to meet. Adios.